let's begin. So what was I saying? I wasn't saying anything complicated, so we can begin and hopefully other people can join us. So here's the idea. I was saying that we can take any value of z. So in this system, z became a free variable, right? So, and we can take any value of z and find a solution. So let's test it out and let's take a value of z. So if I take the value of z to be 0, then xyz becomes minus 2, z is 0, and 3 minus 0 is 3. So 3 minus 2, this is telling me the solution that I found is telling me one solution for this problem is 3 minus 2, 0, and let's just test it out. Let's take this system, let's take this modified system that I was solving, and let's try to see in terms of columns if I really get this to be a solution. So this was the new system that I was trying to solve, and I take x times 1, 2, 3, I take y times 3, 6, 9, I take z times 2, 2, 6, and what I should get is minus 3, minus 2, minus 9, right? Okay, and so the solution that I had was take 3 times the first column, minus 2 times the second column, 0 times the third column. So let's try it out. So this is x equals to 3, oops, excuse me, this is equals to minus 2, sorry, oops, this is 0, and this is minus 2. So 3 times 1 is 3, 3 minus 6 is minus 3, so I get the first value. So the first value checks out. 3 times 2 is 6, 6 minus 2, so notice, okay, let me just write it down. So this is 3, this is minus 2, and this is 0, right? So these are the values that I'm taking, 0 times 2. So 3 times 2 is 6, 6 minus 12, oops, this is not a solution. 3 times 2 is minus 6, and wait, where did I make a mistake? So I'm getting minus 12, and minus 12 plus, this doesn't give me a solution. I have made a mistake somewhere. Let's find that mistake. Okay, so this was minus 2y equals to minus 2, so y should be minus 2. Was this the system that I was solving? 3, 9, 6, 1, 2, 3, 1, 2, 3, 3, 6, 9, 2, 2, 6, minus 3, minus 2, minus 9, and we take any value of z, so that's fine. I take y to be minus 2. Something did not work out. What is that? 3 times 2 is 6. Is that the... did I do the correct elimination? Okay, let's try to do the elimination again, and let's see if we can find the mistake that I made in this system. So, okay, let's repeat this. Row 2 minus 2 times row 1, and over here I get 1, 3, 2, minus 3, and so 2 times 2 is 0, 6 minus 6 is 0, 2 minus 4 is minus 2, minus 2 plus 6 is 4, and then do row 3 minus 3 times row 1, which is 3 minus 3 is 0, 9 minus 9 is 0, 6 minus 6 is 0, minus 9 plus 9 is 0, so 0z. Oh, wait a minute, oops, I made a mistake right here. Sorry about that, I just realized that I was saying something wrong. This equation doesn't tell me, notice that the third variable, this was x, this was y, this was z. The third variable was telling me I can take any value of z, but the second equation was actually telling me this is minus 2, so this second equation is restricting it. It's telling me minus 2z. This third column is for z, not for y. That's the mistake that I made. So this is telling me equals to 4. So to satisfy the third equation, I can take any value of z, but the second equation is telling me no, actually you need to restrict z to be equals to minus 2. So that's a problem. It wasn't y that was equals to, so let's correct that mistake. This was z equals to minus 2, and so now what do we get? Let's let's just, while we're at it, let's correct this entire thing. So what I was actually saying was true for z was actually true for y. So I don't get any, so this is just y, and z has to be minus 2. So this changes my system over here. I get blah blah blah. So x is equals to minus 3, this is minus 4 over there, it becomes plus 4, and minus 3y. So x is actually 4 minus 3, which is 1, 1 minus 3y. So actually this system, the solution that I get is 1 minus 3y, and z is actually minus 2, and y, now for y I don't really have another equation. Y can be, y for x it's 1 minus 3y, but I have no other equation that I can solve for y, so y is the free variable. So y is the free variable. And how do we find what what's your free variable is? The free variable is the variable which doesn't have any pivot. So you start off from the first one, right? So x is not free. And when you go to the second row, you realize that there is a 0 in here. So at this point you can declare y is free, right? So the solution is 1 minus 3y, y minus 2. And so now I can't take 0 to be z to be 0, I can take y to be equals to 0. So one solution of my system will be 0, 1 minus 0 is 1, so 1, 0 minus 2, that should give me the right combination. So 1, 0 over here, and minus 2 over here. So let's check that out. So 1 minus 4 is minus 3, so first value checks out. 2 minus 4 is minus 2, second value checks out. 3 minus 12 is minus 9, third value checks out. So 1, 0 minus 2 is the solution, but that's the solution that I got when I set y equals to 0. I want to set y, I could set maybe y equals to 1, in which case my solution 1 minus 3y, y minus 2 will become 1 minus 3 is minus 2, 1 and minus 2. So that should give me another solution to the problem, and you can verify by plugging in these values over here, here and here, and you will see you will still get minus 3, minus 2. So in this case we have elimination breaks down, but we get infinitely many solutions, right? Okay, is that clear? Right. No longer need this, I can just delete this right here. Okay, so we saw 3 cases today. The first case we saw in a 3x3 system, we said elimination works. We get 3 pivots and we get a unique solution, right? We got only one solution to that problem. In the second case, elimination failed and we got only one pivot. How many pivots did we get in the second case? So elimination failed, but in that case elimination could be saved, and I still got 2 solutions. So in this, a unique solution. Elimination failed, but not really. Elimination was sort of, let's call it elimination works. It was actually saved from failure, and in this case I still got 3 pivots, right? And I got a unique solution. In the third case, elimination failed. It completely broke down and I got, how many pivots was this? So when I got no solution, I had, technically this was a pivot and this was a pivot. So I got 2 pivots but no solution, right? So 2 pivots and no solution. And in the third case, elimination failed. I got, how many pivots was this? So in this case, I got 1 pivot and another pivot. So this tells me I got, again, 2 pivots, but I got infinitely many solutions. So that's something that you can have. Now we did elimination, and one more thing that we realized, that we can do elimination with augmented matrices, right? We don't need to look at the equations over and over again. We just look at the matrix, we augment the right hand side to the matrix, and we just do elimination row by row and get rid of the pivots that we want to get rid of, and that gives me a nice way to solve the system of equations. Okay? Any questions? Any confusions? After this, of course, I want to move to the point where I want to do this elimination process. I want to do elimination with matrices. So let me just give you a sort of a trailer for that, for the next lecture, so that you have an idea of what's coming, and maybe you can try to figure it out on your own. How do we do elimination with matrices? So with matrices, what I mean with matrices, I mean with matrix multiplication, right? So the key point is that the process that I did over here, let's start off from the first system that we solved, let's say this one, and let's take this one, yeah, and let's put it here. Okay, so this was the system that I want to solve, and now I want to do the same thing. I want to do row 2 minus row 1, and I want to do row 3 minus 3 times row 1, and I want to do this process by finding a matrix. So let's say this was matrix A, right? So let's think about a smaller version of that problem. So let's say I have a B, right? Let's take the first one of this, so 1, 2, 3, right? So this is B, and let's think of a matrix that I can multiply with B to get the same thing that I got over here, which was after eliminating the x's from the first and the second row, what I got was this matrix, right? So it had a 0 here and a 0 here. So I want to eliminate these two entries. Sorry, I keep moving back and forth, but here we go. So I want some matrix so that when I multiply it, I get 0 here and 0 here, right? And the first row remains intact. There's nothing that's changing in the first row, right? And so let's think about how we can achieve that. One way to achieve that is to see that when you multiply this, so whenever I have something in here, let's think about, let's put all zeros here, right? When you do matrix vector multiplication, you can also think about it in terms of, so you're taking a dot product, right? So all these entries, 0, will be multiplied with this. So 0 times 1, 0 times 2, 0 times 3. So if I take that, the first entry will become 1. So this gives me 0 times 1 plus 0 times 2 plus 0 times 3. But I don't want it to become 0, right? I want it to stay 1, which means I can save this 1 from becoming 0 if only I changed this 0 to be 1, right? And so I can think of changing this 0 to 1. And so now think about what happens. So 1 times 1 plus 0 times 2 plus 0 times 3, and I've managed to save this 1 over here, right? So it means that if you want to save this entry, if you want to keep this entry, then keep the corresponding entry to be 1 over here. So for example, if I take this one now, so this row gives me 0 times 1 plus 0 times 2 plus 0 times 3. If I want to save this entry, what I can do is I can put a 1 here, and this gives me 1 times 2, right? And so if I manage to do that, I get a 2 here, and if once again if I change this to 1, then this becomes 3. And so notice that what I've actually ended up making is the identity matrix. The identity matrix basically saves all of these values, right? But I don't want to save them. I really want to change these entries to 0. So what do? Now I have saved this value, I have saved this value, but actually what I want to do in the second row is not to save this value, but subtract. So I want to do this process, right? Row 2 minus 2 times row 1, which is basically I want to multiply the first entry by minus 2. So I change this to be minus 2, right? And so notice what happens if I change this entry to minus 2. So this row will now take the first entry minus 2 times 1 and 1 times 2. So 2, so this essentially does 2 minus 2, and because this is 0, this doesn't change anything. So now this entry becomes 0. And now if you think about it, all you need to do the same thing for the third row, first save this entry by putting it 1, and now you want minus 3 times the first row, so minus 3 times the first row. So think of this entry in row 3 and column 1 as the multiple you want to multiply it with the first entry in the row. So this is minus 3, right? So this is the matrix that when you multiply with this vector, it gives you the first entry as it is. The second entry, it changes to 0 because it does row 2 minus 2 times row 1, and the third entry, it changes to 0 because it does row 3 minus 3 times row 1, right? And so this is now this is sort of my elimination matrix. Usually we try to do 1 elimination per matrix, but I've done 2 elimination, that's fine. I'm allowed to do that. Elimination matrix for row 2 minus 2 times row 1 and row 3 minus 3 times row 1, right? And so now instead of applying it to a vector, let's apply this matrix to this whole matrix, right? So I now take this, let's take this and let's ignore this for now, and now let's take this matrix and do some matrix multiplication. So here we have this one, let's plug it here, and let's do some matrix multiplication. And so the matrix multiplication that you do is going to be row times column, right? So the way you do it is you take first this row and you multiply it with each column, this column, this column, this column, and this column. So you get, what we end up getting is the following. Notice that, think about this as a 3 by 3. This is a 3 by 3 matrix. This is a 3 by 4 matrix. When you multiply them together, first I know I can multiply them because the columns align with the rows, and the resultant matrix that I will get is a 3 by 4 matrix, right? Okay, so 1 times the first row, 0 times the second row, 0 times the third row just gives me, so 1, this gives me a 1 here. Again, so what this row is doing is it's preserving row 1. So again, 1 times this 1 times 3 plus 0 plus 0, so this just becomes 3, 2 and minus 3. So the first row becomes preserved because of this entry. In the second row, what you have is you're doing row 2, so this is saying row 2 minus 2 times row 1. So this becomes 0, and this is 6 minus 6, which is 0. This is 2 minus 4, which is minus 2, and this is minus 2 minus 6, which is 4. And again, for this one, it's row 3 minus 3 times row 1, which is minus 3 times 1. So again, you can just look at this entry when you multiply minus 3, 0, 1 with 1, 2.